All right, welcome back. We are back with a brand new video here. I haven't recorded in a super long time, so hopefully this works out. So what we got here is we're starting a brand new unit, as you can see, Unit 4, Natural Logs. It's really just an extension of the previous unit, which was on just regular logs. This is like we dropped the album, Unit 3. Now we're doing the deluxe version of the album, just a couple of extra little topics. So when we have a test on this next week, it's really on it'll take you about 15 minutes to do. It's just, I would call it a quiz more so than a test. All right. And the reason why we break it up into this second subunit on logs is because in this little mini unit, you're allowed to use calculators. In fact, you would have to use a calculator to do pretty much every question in this unit for the most part. All right. This involves using calculators and getting weirder decimal numbers. So if you look at the question on the screen right now, you might say, oh yeah, I just did this in the previous unit and there was a question like this on the test that I just wrote not too long ago. And you would be correct. The only difference is this one, unlike the X and Y intercept questions on the previous unit, this one doesn't work out to be nice integer numbers. Well, actually, I think the X-intercept in this particular case does. Okay, and then you look at the second example, and in both the X and Y-intercepts are integer numbers. So that's what we're going to take a look at today. The format is still the same. You're still doing some algebra, plugging in 0 for X and 0 for Y, but you're going to have to make use of your calculator at some point. So let's get this started. Doesn't matter what you start with. I'm going to start with the y-intercept as I usually do. So I'm going to plug in 0 for x. And when you do that, you're going to have something like this right here. You're going to have y is equal to 2 log subscript 3 of 0 plus 7 minus 4. And of course, you want to take care of the brackets first. Many of you, when you get used to this, you'll just jump right into log 3/7. So we'll just do that right now as another mini step right here. And this is where things get a little bit different because on the test in the last unit, okay, you were doing things like this, but it would be like log 327, log 381, numbers that you could do in your head and get answers that are just nice integer numbers. And in this case, log 3.7, you cannot do this internally. You have to use a calculator. So something that we did in class earlier today was we took a look at how this could be rewritten as log 7 over log 3 with no subscripts. The subscript being an invisible subscript of 10. And the reason why we convert it this way is because many of your scientific calculators are unable to put in the subscript number. Some of you can, right? But a lot of calculators just have log subscript 10 on the calculator. So in this case, this is a way so that everybody can do this. And then from there, okay, you're just going to do log 7 divided by log 3 in your calculator. Both numbers are decimals. You may want to do both and do it all at one time. However, for this first example, what I'm going to do here is just kind of put each one into the calculator one at a time. So log 7, if you're doing this correctly in your calculator, you're going to get that decimal number. So how that works is there's a log button on your calculator. You would hit that, then hit 7, and then equals. Or some other calculators, you had to put the 7 in first and then hit the log button. You'll quickly figure out how your calculator works, but if you're putting these in correctly, you should get these decimal numbers, and I'm rounding to 3 decimal places. And then when you do the calculations here, you would do the division first. So you could, most of you could just do log 7 divided by log 3 in your calculator at once and get 2 times 1.771 minus 4. And when you multiply by 2 and subtract 4, you're going to get approximately 0.458. And of course, because we're rounding off, that's what it's going to look like. And if we express it as a coordinate point, this is your coordinate point right here. And this is your y-intercept that you would definitely not be able to do without the help of a calculator. Now, in this particular case, like I had mentioned earlier, the x-intercept actually works out to be an integer this particular time. Okay, so when you put this in your calculator right here, or sorry, in the equation, you're going to put in 0 for y, and you're going to solve for x, and you're going to see that this one is pretty much what we had done in the previous log unit. Okay, we just put in 0 for y, going to solve for x here. So you can begin by bringing the minus 4 over and making that a positive 4. Just like this right here, and then you can divide both sides of the equation by 2, and they would cancel right here, and you would wind up with 2 is equal to log 3 x plus 7. And here you can see that you can change this into an exponential equation, convert from a log to an exponential equation very easily here. You can go 3 to the power of 2 is equal to x plus 7. You get 9 is equal to x plus 7. And so therefore, x is equal to 2. And there you can see that the x-intercept right here as a coordinate point would look like this right here. And if you chose to, okay, if you didn't have an answer key available, what you could do is you could go on to Desmos and you could take a look at what the graph looks like, and then you could just click on the x and the y-intercepts, and you can see that this just kind of verifies your work. Okay, we're going to do a second example right here. It's the same thing. The only difference in this one is that both intercepts are going to give you weirder decimal numbers. So let's take a look at what we have in this particular case right here. We can start with the y-intercept again if you want. So we can plug in 0 for x. And when we do that, this time out I'll go a little bit faster and I'll skip a couple of minor micro steps. So you're really going to get 0 plus 5 is 5. And you notice here, this logarithm right here, once again, you are unable to solve for this in your head, more than likely. Okay, it's going to be a weirder decimal number. 2 to the power of something is equal to 5. That is not an integer number. So what you're going to do is you're going to use your calculator, and you're going to solve for this by putting in log 5 divided by log 2. You're going to get a decimal number for that when you calculate. You know it's going to be 2 point something. So to be exact, what you're having, or sorry, rounding off the 3 decimal places, not quite exact, you're going to get 2.322. And then, of course, you take that and multiply it by -3 and add 4, and that's going to give you approximately negative 2.966. And then once again, we can write this as a coordinate point. The y-intercept is right here. And next up, let's do the x-intercept. Like I said, this one is going to be a little bit different. It's not going to be an integer number. So let's take a look at plugging in 0 for y. And when we do this, you're going to wind up with this equation right here, and you have to solve for x. Same steps, okay, but you're going to see as we move through this problem that you're going to wind up with a decimal value for x that you can only really get using a calculator. So bring the 4 over, it's -4. And then divide both sides of this equation by -3. And you can see what happens here, okay? -4 divided by -3 doesn't really reduce other than the 2 negatives making a positive. You could change that into a decimal number if you wanted to. Since we are rounding anyway, you could make 4 over 3 1.33. That might be a little bit easier to use, okay, if you use this decimal number. And then you're going to change it to an exponential equation, just like we did in the previous example. But what's going to happen is you have 2 to the power of a decimal number, and that's going to cause some issues because you wouldn't be able to do 2 to the power of 1.333 without the use of a calculator. So what you're going to do is, if you do this right here and round this answer to 3 decimal places, you should get approximately 2.520. You might be off a little bit, okay? If you did, for example, if you did 2 to the power of 1.333, you're going to get 2.519. If you do 2 to the power of 4 over 3 in brackets in your calculator, you'll get 2.520. Just a minor difference, and I don't think it really matters. We would accept both answers. And then, of course, you would subtract 5, and you'd wind up with an answer for x that is approximately negative 2.481, which, of course, you can write as a decimal number. And if you didn't have answer key available, you could check on decimals. That's another way of checking your answer. And there you go. Okay, so what you could do is, if you want to try a couple of questions on your own, we don't actually have a worksheet on this, but you could pause this video, try these 2 questions out, and if you get the answers that are below, then you know what you're doing and you can move on. All right, so these are X and Y intercepts. Let's give these a try, and thank you for watching.